20 most common machine learning and deep learning algorithms and their typical applications. 1. Linear regression. It can be used to predict continuous outcomes based on linear relationships. It is normally used for forecasting and trend analysis. 2. Logistic regression. It estimates probabilities for binary classification problems. It can be used for spam detection and medical diagnosis classification. 3. Decision tree. It models decisions and their possible consequences, used in classification tasks and to model complex decision rules. 4. Random forest. An ensemble of decision trees that improves accuracy and handles overfitting, used in various classification and regression tasks. 5. Support vector machines, SVM. It finds the optimal hyperplane for classification, used in text classification and image recognition. 6. K-nearest neighbors, KNN. It classifies data points based on proximity to other points, used in recommendation systems and pattern recognition. 7. Naive Bayes. It is based on Bayes' theorem with independence assumptions, used in spam filtering and document classification. 8. K-means clustering. It groups data into K clusters based on similarity, used in customer segmentation and image compression. 9. Hierarchical clustering. It builds a hierarchy of clusters, used in gene expression analysis and social network analysis. 10. Principal component analysis, PCA. It reduces dimensionality while preserving variance, used in data visualization and noise reduction. 11. Gradient boosting machines, GBM. It builds models in stages by correcting errors of previous models, used in predictive modeling and competition-winning solutions. 12. AdaBoost. It boosts the performance of weak learners by combining them, used in boosting accuracy for classifiers. 13. Neural networks. It mimics the human brain structure to learn complex patterns, used in image recognition, natural language processing, and more. 14. Convolutional neural networks, CNNs. It is a specialized neural networks for processing grid-like data, such as images, used in image classification and object detection. 15. Recurrent neural networks, RNNs. It is designed for sequential data, used in speech recognition, time series forecasting, and language modeling. 16. Long short-term memory, LSTM. It is a type of RNN that handles long-term dependencies, used in speech synthesis and machine translation. 17. Generative adversarial networks, GANs. It consists of two networks competing to generate realistic data, used in image generation and data augmentation. 18. Autoencoders. It is a neural networks for unsupervised learning of efficient representations, used in anomaly detection and data denoising. 19. Reinforcement learning. It trains agents to make decisions through rewards and penalties, used in robotics, game playing, and autonomous driving. 20. XGBoost. It is an optimized gradient boosting framework, used for structured, tabular data to achieve high performance in competitions.